Hello, this is Teach Nichols, and this video is on creating equations. The essential question is, how do scientists make equations out of mathematical relationships? So step one is something we've already gotten pretty good at, identifying variables. The first variable you need to figure out is, what is the dependent variable? What's the whole point of this equation that you really care about? And what are all of the independent variables it depends on? So sometimes dependent variables depend on multiple things. You got to find them all. So let's say, for example, you want to make an equation to scientifically calculate the niceness of each of your teachers. You decide to call this dependent variable n. As you think about it, you decide that n depends on only two other variables for you: the amount of candy the teacher gives out, or C, and the amount of homework the teacher assigns, or H. So those are going to be your independent variables. So then you're going to figure out what kind of mathematical relationship each of your independent variables has with the dependent variable you're interested in. You could use an experiment or data, or sometimes you can just use logic to figure out these relationships. So you think about the first pair of variables, and you realize, obviously, that when the amount of candy given goes up, the niceness of the teacher also goes up. This tells you that there must be a direct relationship between C and N. A big amount of C translates to a big amount of N. One new way of writing this that you may not have seen before is C fishy N. That little fishy just means proportional to, or directly proportional to. Then it's time to consider the second relationship. When the amount of homework assigned goes up, the niceness of the teacher goes down. This means there must be an inverse relationship between H and N. The bigger the amount of homework, the less the amount of niceness. If you wanted to write this with that little fishy, you would write 1 over H fishy N. And the 1 over signifies an inverse relationship, and you'll see why in a few minutes. Now for the fun part, combining the relationships into an equation. You're going to build your new equation by putting the dependent variable on one side of an equal sign. And on the other side, you're going to put your independent variables. Any independent variables that you found that had direct relationships with the dependent variable are going to go on the numerator, or the top of the other side of the fraction. In this example, we decided candy and niceness were direct, so we put the C on the top of this fraction. Any independent variables that have inverse relationships go on the denominator, which is the bottom of the other side. In this example, we decided that homework was inverse with niceness, so we put the H on the bottom. If later on you realize there's more than just these two variables, you can just multiply them together on either the top of the fraction or the bottom of the fraction, depending on whether you decide they're direct or inverse. So what if we say teachers give you money or stickers? That might make things better. Of course, yelling might make things worse, so we're going to put the money and the stickers on the top with the direct multiplied together, and we're going to put the yelling on the bottom. So this equation can get bigger if you decide that there's more variables that have relationships with your dependent variable. Let's take a second and talk about why this equation building works. It works because the values on each side of an equal sign have to stay balanced. That's what the equal sign basically means. Which means if you change something on one side of the equation, the other side has to change as well. If you change the top of one side, the other side is going to have to get bigger or heavier to stay balanced. If you change the bottom of one side and make it bigger, well, the other one's going to have to get a bit littler to basically balance itself out. We're dividing by a larger number. So this is the reason why building equations this way work, and you'll see it over and over again over the course. The last thing is a really quick example of using our new equation. This equation is now a shortcut that lets you calculate teacher niceness with just a little bit of data collection. You discover teacher A gives 12 pieces of candy and 6 minutes of homework. You can plug these values and their units into your new equation. N equals C over H, so I'm going to plug in 12 pieces of C candy on top and 6 minutes of homework H on the bottom. This can simplify down to a niceness value of teacher A of 2 pieces per minute. 2 pieces every minute. Teacher B, on the other hand, gives 10 pieces of candy and 4 minutes of homework a day. His niceness would be 10 pieces on top of 4 minutes, simplifies down to 2.5 pieces a minute. The reason this is a cool equation is because you might not have known just instinctively which of these two teachers was nicer, but you now have conclusive proof that teacher B is nicer than teacher A. Okay, just a quick summary. How do scientists make equations? How do these equations make sense, and how can we use those equations? Hopefully you can write the answer to this in your own words. Thanks for watching.